All right. Good morning and welcome everyone to this open lecture on machine learning. We have a guest with us here today, Patrick Couch from IBM, more specifically AI and cognitive technologies. And this open lecture is also part of on a course that we're starting on applied machine learning. So if you are interested to know more after this lecture, feel free to apply for that. And I will talk more about that course later. During this presentation, you have the opportunity to ask Patrick some questions, and we will use Mentimeter for that. So you just go on into menti.com and use the code 421397. And you should be able to enter your questions there, and then they will handle those in the end. All right, with that, I just want to give the floor to you, Patrick.
Okay, all right. Thank you for having me. I hope you can hear me okay and see me okay. Everything's working in terms of technology, I hope.
Yeah.
All right. So I will basically spend 45 minutes, I guess, contextualizing artificial intelligence and then hopefully inspire some questions that I will be more than happy to address at the end, as Stefan said. Okay, so I'm Patrick Couch. I work as a business developer and spokesperson at IBM, focusing on artificial intelligence. And artificial intelligence is certainly a very interesting topic, and it has always been a very interesting topic, I guess. And it has become more and more relevant. So I will basically put a bigger picture perspective in place, and then we can dig into some of these more specific elements of it as we go along. I'm sure you have all seen what's happening in the US, and if you look at a picture like this, there are many things to notice here, and I'm not really referring then to the Canadian flag, which I find very interesting. Why is that there? But rather, what does it say about our times and our culture that this is happening and that this did in fact happen? And Facebook's own research revealed that 64% of the time a person joins an extremist Facebook group, they do so because the platform recommended it. So they do so because some algorithm has suggested that perhaps this extremist group would be something to your liking. Facebook has also acknowledged that pages and groups associated with the QAnon extremism had at least 3 million members. So that really means that Facebook's algorithms radicalized 2 million people. Finally, when it comes to Facebook, Facebook also acknowledges that around 5% of the more than 2 billion active Facebook accounts are probably fake. And this is despite the fact that they stop and hinder billions of accounts being created by various bots. And the reason why I address this is because I want to make it absolutely clear that our times is a digital first time. So what happened at the Capitolium is basically the fallout of something much greater and much more primary that has been ongoing for a long time, but it has been happening in the digital arena. A slightly different view into this notion of the digital first era is the peculiar fact that I came across the other day, that 1.2 billion people in China share only 100 surnames. Now, I find that extremely fascinating, and there are a lot of historical reasons for this. And also it has to do with the Chinese character system. But more recently, the main problem that this results out of is that not all Chinese characters have been coded into computer systems. So as China goes into the digital world and puts digital systems in place, they do so and they force people to change their names, because if you have a peculiar character in your name, you won't be able to use the digital tools available to other people. So you can't make online payments or bookings, or you can't identify yourself simply because part of that character in your name hasn't been digitized. So again, it's this notion of the digital domain puts pressure on the physical domain. Now, I went to the US 2 years ago, and I had just bought this great-looking Jimi Hendrix T-shirt, and I was really happy to wear it. And when I came to the entrance at the customs at LaGuardia, I was looking into this scanner that was looking out. It scanned my passport, and then it was supposed to scan my face. But the algorithm in the machine didn't understand what it was looking at, which surprised me because I was just standing there looking into the machine. And then the security officer came and said, "You have to cover the eyes of Jimmy." So I covered the eyes of Jimmy, and then the machine understood what it was looking at. So again, this idea that we have to sort of put ourselves at the hands of our technology has been really, really concrete today. And I'm sure you guys are all aware of the Turing Test and this notion of if you can't determine whether or not you're interacting with the machine is intelligent. And the CAPTCHA, the reCAPTCHA tests are there for the machines to be confident that they are in fact interacting with a human. So we are exposed to, oh, check out these pictures, where are the bridges? And then we identify the bridges, and then the machine says, oh, okay, that's probably a human then. So in summary then, to set the scene a little bit, I would like to quote Terence McKenna. And Terence McKenna's insights into the culture that he was living through was vast and quite impressive. And he said, the primary contribution of 20th century thinking is to have understood that information is primary. And he drew the conclusion that in many ways the world is made of language. And he said that the implications for the digitality is that reality can therefore be hacked. And I think this is what is going on the larger scale, right? We are putting in place a technological dimension that then takes precedence over our physical one. And in this larger context, artificial intelligence is certainly the most relevant or problematic or challenging or promising, depending on your sort of angle, out of all the technologies that we are working with now, that we are going digital. And this has, of course, been the topic for a lot of discussion over the years. And I'm sure you are aware of Alan Turing's famous paper, Computing Machinery and Intelligence, that he published in the 50s. And in that paper, he asked this very interesting question. He asks, can machines think? And that question has sort of haunted a lot of people for a long time as we had stood up more and more capable technologies. At the same time, over the years, there's been this inflated expectation of what technology can do. And we've talked about these AI winters that have hit us every now and then. And there used to be a time when people published books like the one that Hubert Dreyfus published at the end of the 70s, where he said what computers can do, the limits of artificial intelligence. So he put a stake in the ground and said there is a limit to what they can do. However, today, there's a completely different type of book being written, and it's a book that is very open, horizon-oriented. And perhaps you've read Max Tegmark's Life 3.0, or you've heard of Ray Kurzweil's forecasts about the singularity, or Nick Bostrom has written eloquently about superintelligence. And all of these books sort of take for granted that we know what we're talking about, but we don't. There's a challenge when it comes to artificial intelligence in terms of defining it. And there was a paper published last year, or 2 years, at the end of 2 years ago, where Pei Wang spends 25 pages trying to define what it is. And so I sympathize with this because artificial intelligence is quickly subsumed or reduced into specific areas. But for my own sake, I have made it more simple for myself. So I basically say artificial intelligence is intelligence without biology. So that makes it more easy for me to navigate these matters when I'm out talking and trying to get people to adopt certain technologies. But that raises the question of what intelligence is. And although it may not be that easy to define either, I think that you can look at 4 aspects of intelligence to sort of get a little handle on it. One is that I certainly would expect an intelligent system to have some sort of understanding. And by that, I mean a way of contextualizing the question. So it's not the calculus figuring out that 2 + 2 is 4, which is independent of context, but it is more about taking into fact other things, secondary elements perhaps. Also, I would expect a certain element of reasoning, so that it's not about finding a single answer. It's about discussing, problematizing something and reasoning back and forth around a topic. That's intelligent to me. Also, I expect learning to come into play. I want the systems to improve over time. I want them to learn from the interaction in this context in which they are reasoning. And finally, there is that element of expectation when it comes to the interaction between the intelligent system and me as a user. So if you think about conversational interfaces, chatbots, to the extent that they are pleasant to talk to and to the extent that they do sort of understand our intent, they are more intelligent. That is not always the case. But if these 4 elements are in play, I would certainly feel that we are sort of in the presence of intelligence, whether or not it is technological or biological or analog. And if you think about how intelligence has evolved, you can get a better understanding of what artificial intelligence really is about. And it's an interesting fact to me that humans and chimps share most of our DNA, but the human brain is 3 times the size of the chimp's brain. So that's just an interesting fact to me, and I pondered about this. And another interesting fact is that once we split off from that common ancestor, nothing much happened in terms of the brain size until around 2 million years ago. Then all of a sudden we saw this huge increase in the brain size. If you look at the skeletons of the head of humans. And this is a discussion ongoing in science today. There's no clear answer for why this happened and why it happened so quickly. There are a lot of different theories, a lot of interesting hypotheses. But I'm sort of, for the sake of this lecture and for the sake of grappling with artificial intelligence, I sort of side with Stanley Kubrick. And I don't know if you saw his fantastic movie 2001, A Space Odyssey. But in the beginning of that movie, there's that dawn of human or dawn of man sequence. And in that scene, there is a realization that happens where one of the proto-humanoids pick up a piece of a bone and uses that as a tool. And to me, then that's the trigger. That's when when humans strike up a relationship with technology. And once we do that, we evolve very differently from chimps. Now, of course, the trigger for why we realized we could use technology is perhaps still not made clear. I mean, in the movie, it's because that monolith comes from space. But regardless, I'm thinking humans struck up a relationship with technology, and that made us very different from the chimps. However, of course, I mean, as Jane Goodall proved or showed in the 60s, I think, chimps do use tools as well. They do use technology for sure, and other animals in the animal kingdom do, but they don't really do it the way humans do it. Humans have a completely unique relationship with technology that I think is very interesting and that I think has bearing on the topic of artificial intelligence. And one way of approaching this relationship is to think about it in terms similar to the ones that Marshall McLuhan outlined in his famous book, Understanding Media, where he spoke about the extensions of man. And he made to me, a very interesting and worthwhile delineation of the topic. And he said, technology is basically the same as media, culture, language, art, artificial intelligence, tools, everything, all of these things are basically the same, because what they are not ideas, feelings, intelligence, experience, imagination. But these 2 domains have a relationship between each other, and that is the one gives the other. And he then spoke about the extensions of man. And he said, well, once we think about technology as an extension of ourselves, we can see that the more technological we are, the more human we are, in the sense that we are different from other animals. And once we struck up that relationship with technology, things went very fast. And today, I mean, just these past 50, 60 years, we put a man on the moon. We have sent our technology outside of the solar system. We've landed a rover on Mars, which can take selfies. And Elon Musk has sent his Roadster into space. And this has all happened very quickly. And I think, again, Terence McKenna captured this very eloquently when he said, one moment you're hunting ungulates on the plains of Africa, and the next moment you're hurling a gold terbium superconducting stellar device toward Alpha Centauri with all of mankind on aboard in virtual space being run as a simulation in circuitry. It's just first the one thing and then the other thing. That's how fast it goes. And that also is how fast artificial intelligence is evolving. Now, when we talk about the difference between humans and machines, or humans and technology, and when we're trying to sort of play around with it, with understanding and coming to terms with artificial intelligence, I think it is worthwhile to note what Ludwig von Bartholomä said in his book, General Systems Theory. And he said, people are not machines, but in all situations where they are given the opportunity, they will act like machines. And I thought about that, and I noticed that, well, the inverse is sort of true. Machines are not people, but in all situations where they are given the opportunity, they will act like people. And to me, that is really what's happening now in terms of the evolution and involvement of artificial intelligence. And perhaps you saw, or perhaps you've kept an eye on what Boston Dynamics are up to in terms of creating very sophisticated robots. And they did release this fantastic video at the end of last year, around Christmas time, where these robots were dancing to Do You Love Me? And there were two of these Atlas robots. There was one of those dog robots, the Spot, and then a fourth one. And it's amazing, but that is not really what I'm thinking about when I'm thinking about technology becoming human-like. I'm thinking more along the lines of intelligence and the evolution of intelligence in our technology. So in the mid-90s, the intelligence of technology, or artificial intelligence limits, was sort of around the level of playing chess, right? So IBM was very successful in teaching technologies and computers to play chess, and we had these games with Garry Kasparov where we were successful. That was in the middle of the 90s. 2011, technology and artificial intelligence had evolved to the point where it was better at playing Jeopardy than any human being on the planet. And there was this great splash in the news where IBM put up this Jeopardy challenge, and we had Watson, the Watson brand and the Watson technology play Jeopardy. And what was amazing with that breakthrough, or that achievement, was that it showed that technology, artificial intelligence, could actually parse language and understand seemingly language. So it could actually figure out what question to pose to the answer it was given, and it could do so very quickly. And it was not about just having access to all the right questions and then picking one in some rule-based way. It was really the beginning of this rapid progression of natural language processing and natural language understanding. And so I'm thinking maybe my 2-year-old son is joining the lecture, we'll see. Anyway, 2011, right? And then what was this? Maybe 2016, 17. Google was very successful in evolving technologies or intelligence that could play the Chinese board game Go. And what was amazing with that was that the initial version of AlphaGo was that they were able to use reinforcement learning and benefit from all the thousands of years of expertise that humans have achieved by playing Go for so long. And then they took all of that expertise, they took the rule book, how to play Go, they took all the tactics, all the tips and tricks that these human great players had accumulated over time, and they fed that into the reinforcement models. And then out of that came this fantastic capability of playing Go, and it just outperformed humans very quickly. However, what was even more amazing was that just less than a year later, they did away with all that access to previous expertise and previous experience. And they basically said, well, Mr. Technology, you will have to figure this out yourself. So you will get the rules for the game, what you can and cannot do in Go, but you won't get any expertise. You won't have no experience, nothing. And then that very quickly outperformed the first AlphaGo version, so AlphaGo 0. And that was amazing, and it shows how quickly things are evolving. Now, OpenAI is also a group that does amazing work in artificial intelligence, and they have pursued also this gaming avenue, and they showed that they could figure out a way to have technology and algorithms collaborate, and by playing this game Dota 2, where you basically team up, 5 players team up, and they play other teams of 5 players. And Google basically said, well, okay, so not Google, but OpenAI said, well, okay, algorithms, you will have to collaborate now to achieve a greater end. So it's not about maximizing the single algorithm's target, but it's about collaborating for something else. Also, I'm sure you noticed the Google Duplex announcement a couple of years back, and that was also quite amazing. And what was interesting with that was it was so successful in coming off as a human voice or human persona that people were upset that they weren't informed that they were in fact interacting with an artificial intelligence system. So when Google Duplex called up the hairdressers to make an appointment or ordered the pizza, it really sounds like it's a human being that is doing that, but it's not. And it was so successful that people felt almost a little cheated, not having been informed that they were interacting with a machine. Again, the link back to the Turing Test. And of course, things haven't stopped. IBM continued this natural language understanding quest and put out 2 years ago Project Debater, which is basically a neural network very capable of debating with humans on specific topics. And in fact, again, we squared off with one of the greatest debaters out there in a debate competition, and it was quite successful. It didn't beat him at that time, but it was still impressive. And this is a picture from the Cambridge Debate Society, where the Project Debater AI is supporting the debate teams. So it is so human-like in its parsing and working and machinations of language, manipulations of language, that it can be part of a debate team debating something. And debates are very interesting because, again, to reference back to the concept of intelligence, debates are not about being right. Debates are about being seductive. It's about convincing other people that they should also agree with you and consider that you are right. But it is not about the truth. So it's not about finding the needle in the haystack, if you will, of that nugget of the single truth out there. What is in fact the gravitational pull of something, or what is 2 + 2? What is it really? But it's about trying to seduce people and influence people and have people agree with you. And again, it's amazing to me that technology can perform at this level. Now, there's sort of no end, it seems, to these breakthroughs as we move along, right? And maybe you heard of GPT-3 and the amazing feats of language generation that it is capable of. And there was a Guardian article last year in which a GPT-3 model had written an editorial piece basically, and it was when you read that piece, it really feels like it must have been written by a human, but it is not. Have the model write 3 or 4 or 5 different versions of that piece, and then the editorial board edited it a little. But that's also the way they do with like human journalists, right? And then just my final example to hammer home the point of what technology is capable of. At the end of last year, Google DeepMind announced that they had figured out a way to perform very well in non-perfect information environments. So again, it's amazing. However, there is sort of a but or a wait a minute type of thing here, and that is when we do these things, when we achieve these amazing technological breakthroughs, and when we train these systems to really become very intelligent, and perhaps you saw OpenAI's amazing manipulation of the Rubik's Cube, where they have a robotic hand, very dexterously manipulate the cube, solving the cube and using visual recognition to figure out whether or not it has solved it and all of this stuff. The energy consumption for training that specific model, to train the robotic arm to be able to solve Rubik's Cube, cost energy-wise the equivalent of running 3 nuclear power plants full throttle for 1 hour. So it's estimated that it required almost 3 gigawatt hours of electricity. And that is, of course, not tenable. It's not sustainable. It won't scale, basically. And so the energy dimension of powering this evolution of intelligence is problematic. And it's estimated that communications technologies, electricity usage could contribute up to 23% of the globally released greenhouse gas emissions in 2030. So that's, of course, not at all sustainable. So there needs to be, like John Kuhn of IBM said, a reduction of the environmental impact of technology. Otherwise, it won't be able to continue evolving. And I think a lot of these big tech companies are in fact addressing this. And so Microsoft announced that they will try to be carbon negative by 2030. Google is using artificial intelligence to figure out how to be more intelligent in terms of running data centers. And that's all great. And I think it needs to be addressed, it needs to be solved. But there is another element that also needs to be addressed when it comes to applying artificial intelligence and standing up these amazing capabilities. So switching gears a little bit here now, if you think about artificial intelligence broadly and what it can do, I'm sort of often arguing that it can only do 4 things, but it can do 4 things. It can optimize something. Artificial intelligence can figure out how to do something really, really well. It can also help automate something. So you don't have to have human intervention in place. You don't have to have the human in play. You can have a lights out factory, if you will. You can also have it amplify or augment something. And you can basically recognize patterns. You can use it to derive insights into vast data sets that are perhaps not parsable for humans. But these 4 capabilities, once applied, once we go from the theoretical ideation of artificial intelligence and we apply any of these 4 or a combination of these 4 capabilities, we move into a very problematic domain. Now, we are seeing the end of the Donald presidency, which is great, but he has really shown how or why it is problematic to use technology to extend or augment or enlarge yourself. And now we got shut off from Twitter, which was late in coming, but a good thing. We've also seen the dangers of being really good at recognizing patterns and parsing data. And Mark Zuckerberg can say all he wants about the future being private, but they did sort of give out a lot of information to Cambridge Analytica, which then they parsed and saw patterns in and then used for different purposes. So what this leads to is basically that as technology and artificial intelligence is becoming more and more capable, it is in fact becoming more and more human-like. But the human in itself, or we are flawed, I guess. And I think in Nietzsche's beautiful phrase, the great thing about humans is perhaps that we are too human. The human factor comes into play. And once we have that in technology, we will see things such as the self-driving car, in fact, killing people. Very similar to fatalities caused by human drivers. We will see the challenges of standing up automated processes without human intervention. So when Amazon tried to have an artificial intelligence system help them recruiting new employees, it turned out that it was biased against women. And that is, of course, not because, it's not necessarily because Jeff Bezos is biased against women. It's just that people haven't thought about what it means to actually train algorithms on skewed data sets. And so they sort of stopped that. But the reason for trying this out is, of course, completely understandable. I mean, Amazon is recruiting, I think they're currently looking for 100,000 new employees. So they need technological support, and it's understandable that they pursue this, but it is quite challenging. And we also saw, Apple getting some heat because of their seemingly sexist credit card technology, where they actually rated the credit score of people differently based on gender. And that was very unfortunate, of course, and they addressed it. But what was very interesting initially was that they could not initially understand why it did so. They didn't understand why it was scoring, why it was biased against women. So that sort of has become this is known as the black box problem within artificial intelligence, right? Where we have super vast data sets, we have super complex algorithms manipulating that data, and at some point it becomes very difficult for humans to understand what's going on. So there's a lot of pressure now to stand up explainable AI, and good AI, I guess. We've also seen the problems of visual recognition capabilities. And again, with the pattern recognition, you can certainly have algorithms parse data, visual data, and understand what it's seeing, but it also risks being biased depending on how it's been trained. And Google has again and again caught fire for this because their vision AI has, in essence, produced racist results. So that doesn't really work for us. I mean, we can't scale that type of technology in any sustainable way. So rounding off a little bit here, then, I want to sort of end on a, not a negative note, but rather a, I guess I want to end on a positive note. But to get there, we need to address what Stephen Hawking, Bill Gates, Elon Musk, and others have raised, and that is, there is a problem with artificial intelligence. There is a challenge for us that we need to overcome in order to be successful in reaping the rewards and realizing or manifesting the possibilities and realizing the promise of artificial intelligence. And I think what this basically comes down to, why these people are basically saying it's, artificial intelligence can be the end of mankind and all of that stuff. What is really being said here is something that I think Elon Musk said very well, or a point that he made very well when he was on the Joe Rogan podcast that first time. And Joe asks him whether, any future artificial general intelligence would be bad or evil. And Elon Musk says, it's not necessarily bad, it's just outside of human control. And I think this is the point. This is why we need courses in applied machine learning. That's why we need data scientists like yourselves to really think about the implications of what we are doing when we are extending ourselves into technology, and technology then rapidly scales out the impact, because we cannot control it in terms of regulation. We can control it a little bit with regulation, but we need to control it through understanding. So we need to understand what we're doing. And the way to do that is to make sure that, as H.G. Wells, the sci-fi author, noted, we need to make sure that it's education that wins, basically. And he said human history becomes more and more a race between education and catastrophe. And I think that is why education is so extremely important. We need to be educated in terms of users of technology. We need to be educated in terms of developers of technology. And we really need to make sure that what we are in fact pursuing is intelligence. Because I think, like Terence McKenna, intelligence is what we have to make the forward escape into hyperspace and really make the most of our promise. So I think with that, I will end and open up for questions.
All right, thank you very much.
Thank you.
It's very interesting with this very larger perspective on AI. If you want to ask some question for Patrick, we have this Menti where you can log in and ask your questions. You go to menti.com and you use the code 421397. You should have seen it during the presentation as well. Because there's some delay before the questions show up, I'm just going to talk a little bit about this course that we're starting here afterwards. So we have this course on applied machine learning, which is on 3HP, which is also created for working professionals. So it's a low-paced course that you can also sort of work at the same time as you're taking the course. And it actually also has this win-win type of project in the end of the course, where you can actually take like a problem you have in AI machine learning where you're working, and you can do it as a project. But basically this course, Applied Machine Learning, it's still open for enrollment. So if you found this lecture very interesting and want to know more, maybe know more about the technology, we will focus a lot more on sort of the applied side, you feel free to apply. The next lecture is 2 weeks away, so you have these 2 weeks to apply. Basically, like I said, it's 3HP, it's 10 weeks long. It's on advanced level, and it's of course free of charge because it's a regular university course. And it's made for working professionals, slow speed, flexible format, and it has this possible of a win-win project in the end. So if you want to apply, the easiest place to go is to is to our website, mion.se/iprof, and iprof is the name of the project that this is a part of. It can also be found on antagning.se because that's where you have to apply for it. So you can just use the code that you can see here. The requirements for actually taking the course is that you need to have a bachelor's degree in computer science, computer engineering, electrical engineering, or something equivalent. And you also need to have 15 HP of programming, because we are quite applied in this course. So we do some programming, Python and TensorFlow and stuff like that. Yes, and the reason for this, why you need a bachelor's degree, is because the course is on advanced level, so that's why we have it. All right, I think we go to the questions. You still here, Patrick?
Yeah, yeah. Absolutely.
Let's see if I have the questions here. Okay, we got some questions here in the beginning about the ethics, and your questions was, or your talk was very much about this. So what are your thoughts on ethics regarding machine learning and extensions of AI? Might regulations be necessary in the future? Do you think that?
Well, so I'm sort of an anarchist at heart, and I don't really like regulations as a concept, but I do think they are necessary, and I do think we need to regulate. I don't think we can self-govern ourselves into a decent future, seemingly. So I do think that initiatives around ethical considerations and ways of regulating technology generally will be crucial for a sustainable future. So I think that if you look at the various discussions in forums such as the European high-level expert group on AI, I think that is very important. And I also think that the ethical side of technology and its perhaps the manifestation into regulation needs to be thought of not in terms of technology really, but in terms of the ethical side or the humanities dimension of this. So I do think that we need to team up. Like technology needs to team up with the humanities, because ethics have been discussed forever, and there is certainly no answer in place, right? What is good, what is bad, all of this stuff is wide open. But because of this, because of the impact technology has on our society and on our lives, because of that impact, we really need to think about how should it work for us. So when China, for instance, creates this national identification system and they don't digitize all the characters in their language, forcing people to change their names, I think that's very unfortunate. And I think it is great that we have digital online means to do different things, but it mustn't be done at the expense of the human dimension, I think. So I do think that ethics, and I think ethics as a topic has become very central to technology and to AI today. So I do think that people realize the need to mitigate biases, to make sure that we don't cause problems once we extend and accelerate and scale out these amazing capabilities.
Mm. Yeah. Thanks. So this next question is also a little bit connected to that, I think, and it's based on this biased thing, the black box of AI and stuff like that. So the question is, if we don't understand why AI answers are biased, isn't that a consequence of us needing AI in the first place to help us with things we don't understand?
Yeah, yes, that's a good question and a good insight. And I do think that everybody doesn't need to understand everything. Generally, for instance, if I go on an airplane, I have no idea how that actually can fly, right? I don't know if the engineers have done their work in maintaining that aircraft. I just trust the fact that it's not going to crash. And so I think that element of trust needs to be allowed to be in play. But I do want somebody to understand what's going on and how it can fly and how was it serviced and all of that stuff. And for that, I do think that we need technology to understand technology, and we need artificial intelligence to help us understand artificial intelligence. And I think we're seeing this in these various auto AI and auto ML approaches, right, where we actually try to manipulate very large data sets in very complicated and complex ways, but then we have AI to package that work in a way that makes it possible for us to understand it. But then we need that audit trail. We need to be able to reverse engineer ourselves back if need calls for it. So yeah, I think we are sort of there's no going back, right? We're not going to cease with technology. There's no cease and desist coming into play here. So I think we just need to continue with the educational track and really educate people. And part of that education, one of those tools will be technology itself, I think.
Yeah, I agree. I think it has a lot to do with learning and stuff like that. The people learn about it, what it is and what it isn't. A lot of what you talked about. The next question is about hardware. So what do you think about hardware capabilities in terms of implementing AI? Do you see any shift in technology regarding hardware required for AI?
Well, so hardware is really, the underpinning of why this is working in the first place. I mean, the wetware of the human brain uses biology as a substrate for executing the computational tasks of the human mind, and hardware is really the underpinning of artificial intelligence. And I do think that we're coming up against a limit in terms of what traditional hardware can do for us. I mean, we have certainly seen over the years amazing breakthroughs, and I mean this recent shift from traditional CPUs to the graphical ones and other aspects of technology. We've seen that we have sort of made more efficient the traditional compute hardware, but I think that excuse me, I think that there will have to be a breakthrough. Excuse me. There will have to be a breakthrough for us to really see the magic realized. And I think that quantum computing holds out that promise. So it'll be very interesting to see what will come out of a completely different paradigm in terms of approaches to computation. I don't know if that was a rambling answer, but
yeah, no, it's but it is interesting. I mean, with the paradigm shifts in the technology that has really enabled more of this to become much more easily available, I would say.
I think just another note, I guess. I think that there is still a lot of slack in the system in terms of I don't think we are very optimized or efficient in our current way of standing up certain neural networks or certain computations, right? So I think there's a lot of unnecessary work being done, and this is being worked out. So I think we will see a vast improvement in performance without the need for additional energy consumption, for instance. So I think there's a lot of work possible to do. But I also think that what is really interesting is the shared resources approach, where although it is certainly so that some of these capabilities, they have latency demands that make it currently not possible to use a distributed hardware platform. But I do think that there is a lot of hardware out there that is unused. And I think like the world, what's it called? I forget. Anyway, there are these various interesting shared resources approaches. So I think that can also be leveraged to a greater extent.
Yeah, I agree. I mean, as myself, as an Internet of Things researcher and stuff like that, we see that there is a lot of devices that just sitting idle. That may be hooked up to the power lines, but not really doing anything. So we have a lot of untapped power. So could we have better intelligence by human-machine collaborations? Could we reach human explanation from black box? Connecting back a little bit to this biased part.
Well, I think that the human-machine collaboration is probably the way forward. I think that was it Kasparov who said that when playing chess, I mean, you can benefit from interacting and teaming up with the machine, right? And I think the collaboration is very interesting. And just look at, for instance, what is happening now in terms of customer service or customer fulfillment, where you have, on the one hand, you have these fully automated customer support systems where you have a chatbot basically being trained on whatever types of questions generally come to the customer support desk. But and some are good and some are not so good. But what is also happening is that you're seeing these collaborative approaches where perhaps you are in fact interacting with a human customer satisfaction fulfillment agent, but that person, that agent in itself relies on information AI systems that are in real time listening to the conversation and pulling up and pulling out information that perhaps the agent wasn't aware of that is relevant to the conversation. So we're seeing these collaborative approaches, and I think that is very, very interesting. And I think we will, as the interfaces are improved, the interaction between humans and technology will improve, and we will see better performance, greater capabilities being stood up. So, I mean, just the fact that we are moving away from the keyboard and we're moving into the the conversational services or the visual ones or the AR VR thing. I think all of that in combination shows that human-machine collaboration is the way to really achieve great performance or solutions to problems.
A little bit of a follow-up to that, actually, because I think you touched upon it a little bit here, that we see this quite broad range of AI machine learning system working very good, which you have talked quite good about, or also even though biased. But we also see these ones, the cases where it doesn't work so well. So the question is that why is Google Translate so bad if AI works so well? So do you have any thoughts about that?
Yes, well, I think that, again, this is really a question of inflated expectations. I think we're demanding too much, and some of these technology companies are banging the drum too quickly on achievements. So when you see these enormous language models being stood up, and you're saying, oh, well, there was just recently announced, the expansion of the GPT-3 model, and it has like trillions of parameters and all of that. And we're saying, but now natural language processing is on par with humans. At the same time, we're seeing these complete failures in terms of performing, at the level of a toddler even at times. So I think we are expecting and demanding too much, too soon, too quickly, and that is partly the fault of marketing efforts by technology companies. And also, I mean, it's, again, with the scale, technology scales so tremendously well, so that when it goes wrong so stupendously wrong. I mean, it is amazing how wrong it can go, right? And you're thinking, how can it not see that it's not a donut, it's a dog? I mean, obviously it is. So it becomes very stark, or the contrast is very out there. So I think, again, I do think that technology makes us human, and I do think technology holds up a mirror in which we see ourselves. And that's why when we see these biased, ways of producing results, it's a reflection of our own faults, right? And we have transferred those misunderstandings or unaware tendencies into technology, but then technology makes it visible to us, and we see it and we go like, Jesus Christ. And there are these, what is it, like 120 or so confirmed biases, and a lot of us carry around a lot of those without knowing. So what are the unknown unknowns? And we don't know, but then technology shows it to us, and I think that's what's happening. So on the one hand, we're seeing these fantastic, well-performing systems, and then all of a sudden it just goes completely bananas, and we think that's hilarious because that's not the way humans go about making errors, really.
Yeah. Good. So I mentioned in the course, the course we are focusing on Python and TensorFlow and Keras, but we also have a question here is, does IBM support any open source AI platforms? What do IBM do in this area, basically?
Yeah, so IBM has really decided to go all into the open source community, and IBM has a great history of supporting open source initiatives, and we've sourced a lot of code to the open source community. And IBM's approach is really this open platform thinking, where we are, if you want to work with IBM technology, such as some of these bias mitigation technologies, you can still do that, and you can still leverage any other proprietary or open source code or framework in that environment. So IBM isn't shutting the door on anything. So if you prefer TensorFlow, you can still work with some of these Watson technologies in combination, right? So IBM's point of view is really that open source and collaboration is the way forward. And also we've stood up in the research community certain KPIs or models that are there for everybody to use and further expand upon. So yeah, IBM is not a lock-in proprietary oriented company at all.
Yeah. And I think we go to the final question here. I don't know what you're going to say about it, but basically the question is digital currency and AI. What comes into your mind regarding that?
Yeah, that's a very interesting area that I really know very little about. I'm intrigued by the notion, but I can't say that I understand it well enough to really give a good answer. I do think that as we digitalize our world, a digital currency will come into play and it will be a force. And I think it goes back to understanding the sort of the underpinnings of the current currency system. But I can only say that it's probably going to be a decisive element of the digital future. I cannot see it not coming into play. So I'm intrigued by it, but I don't quite understand it. I don't.
Yeah, I agree. I mean, at least from my perspective, it's like, okay, when we start having AI buying things for us automatically, and then it starts to become, a little bit scary, maybe.
Yeah, and I think, I mean, I'm a big fan of the universal basic income idea. I think during the pandemic, when people have been sort of locked up at home and perhaps not doing a lot of the stuff that we do otherwise, a lot of creativity has been shown. So I don't know if if you look at Twitter and some of the feeds and stuff, but people come up with the most amazing things when they are not required to do a bunch of other things. So I think that if we can have AI automate a lot of the tasks that we tend to sort of associate with work, and we say, no, you don't need to work to earn money. We can approach it differently. And out of that, I think will be a freeing up of creativity and a more interesting future. So I'm not saying that the current way of setting up universal basic income is perhaps feasible, but I do think that we need to figure out a way of automating tasks that aren't really, for us humans to do. I mean, you know how they say, the dull, dirty, dangerous jobs, everybody's happy to see automated. And I think that is true. And I think today, a lot of us, we execute tasks as part of our work because we are forced to. But if I could do away with them, I would be super happy to just be on a universal basic income and fiddle about with my own creative projects or, so I think the movie Wall-E is a bleak view of humans not having anything to do. I think that if we could not work but still sustain ourselves, creativity will come into play more and more. So
yeah. All right. So I think that was all the questions we have for today. So I want to thank you again very much. It's been very interesting talk here, and very interesting discussion as well about the ethics and the implications of AI and stuff like that. Like I said before, we have this course that is more focused on the technology and implementation, so it's applied machine learning basically. But of course, ethics and stuff like this is a part of it as well. So with that, I want to thank everyone for coming here and listening and providing some questions and for the discussion. So thanks again.
Thank you.